Next topic, dissolved oxygen, DO. Dissolved oxygen. It is the amount of free or non-compound oxygen that present in a particular amount of water. Free oxygen or non-compound oxygen, that means O2, is present in water. It is called dissolved oxygen. It is actually a parameter that decides the quality of water as it can affect aquatic life. It is a parameter that decides the quality of water as it can affect the aquatic life. The amount of dissolved oxygen that depends on temperature, pressure, and the presence of oxidizable organic matters. So the amount of dissolved oxygen, it depends three different parameters. One is the temperature, second one is the pressure, and third one is the presence of oxidizable organic matter. At 20 degrees Celsius, the dissolved oxygen level is 9.2 ppm, and at 30 degrees Celsius it is 7.8 ppm. That is, as temperature increases, dissolved oxygen level decreases due to the decrease in the solubility of gas or increase in the kinetic energy of gas. Here I just mentioned an example. As temperature increases, what happens to the dissolved oxygen level? Here we can measure the level of dissolved oxygen at two different temperatures. One is at 20 degrees Celsius and the other one is at 30 degrees Celsius. Look at the level of dissolved oxygen. At 20 degrees Celsius it is 9.2 and at 30 degrees Celsius it is 7.8. So as temperature increases, the dissolved oxygen level, it decreases because the solubility of the gas is to be decreased. At the same time, the kinetic energy increases. So as temperature increases, movement of the particle increases. Then the amount of dissolved oxygen level decreases with a decrease in pressure also. In high altitude, the amount of oxygen in water is low. Then how we can estimate dissolved oxygen? We already did the experiment in the lab. The method used is called Winklers Method. Estimation of dissolved oxygen can be done with the help of Winklers Method. So here we can fill water in a 250 ml bottle, add 2 ml of manganese sulfate, and we can also use alkaline potassium iodide. Then the bottle is closed and shaken well. An yellowish brown precipitate of manganese oxide is formed. Then it is allowed to settle for 20 minutes. Okay, so first we can take 250 ml bottle, then manganese sulfate, alkaline potassium iodide, etc. is to be added. Then we can obtain a yellowish brown precipitate which is formed because we can shake it well. Then after that we allowed to settle for 20 minutes. Okay, then what is the next stage? The precipitate formed is, we can use the precipitate and it is decomposed by adding concentrated sulfuric acid drop by drop. It releases the nascent oxygen which oxidizes the iodide ion into iodine. Okay, so concentrated sulfuric acid is added. So the precipitate disappears and we can see the brown solution there while doing the experiment. Then 100 ml of iodine water into a conical flask and filtered it against standard sodium thiosulfate solution, and we can use the indicator as stars. And at the end point, the blue color of stars disappears. So from the titer value, we can observe the amount of dissolved oxygen. We did this experiment in the lab, Thio method, or this is called Winklers method. When starch is added to the solution, what happens? The solution becomes blue in color. When it is titrated against dissolved oxygen, titrated against sodium thiosulfate, the blue color disappears. And from the titrant value, we can find out the amount of dissolved oxygen.